So your strategies when you're trying to solve these is look, first of all, to replace expressions with something that they are equal to. So you're looking to replace, say, if you saw tangent of x, you could replace it with sine of x over cosine of x, that sort of stuff. You could replace equal with equal. One strategy that to look for using is, it doesn't always work and sometimes it makes problems more complicated. But if you've got a very simple looking question you've been given, if you can't see any fractions there, and particularly if nothing is squared, then try this technique, it might work. Leave anything that is a sine or a cosine just exactly as it is. Don't replace it with something else. But if you've got, for instance, a secant, replace a secant with 1 over cosine. If you've got a cosecant, replace it with 1 over sine. If you've got a tangent or a cotangent, don't replace them with their reciprocal. If you've got a tangent or a cotangent, replace them with these, the quotient identities. Then everything you have written out from the start to the finish will all be in terms of sine and cosine, and maybe things will cross out, maybe things will cancel, okay? If you've been given more than one fraction, if you've been given 2 separate fractions or 3 separate fractions, consider putting them all together over one common denominator so they all belong together in one fraction, and things might really help there. And how you do that is when you combine them over a common denominator, you're multiplying each individual fraction by a carefully chosen form of 1. So the numerators are going to change probably. Look for difference of squares, and I'll talk about that in a little bit. Factoring we haven't done. I'll come back to this slide in a second. So here's your warm-up. I'm giving you 2 minutes on your warm-up. Off you go. So what you're not doing, you don't have an equation. You don't have an equation where you've got something equals something else. When you have an equation, you can do anything you like as long as you do the same thing to the same side. If you have an equation with an equals, or if you wanted to, you could square both sides. If you wanted to, you could add 100 or any number you like, as long as you do it to both sides. If you have an equation, you can divide both sides by the same thing. Whatever you want to divide them by, you can. That's only true if you have an equation where you have sides and you can do the same thing to both sides. With these, you have an expression. You're not allowed to change it in any way, shape, or form. Every line, and with these as well, your answer isn't the most important thing at all. What you finally end up with is, the way I'm grading your work today, what you end up with is only 10% of your grade. 90% of your grade is showing what you've done. So you can't do work in your head. What you must do is you must start each line with the equal sign and write this entire expression on the next line. You can't just write, say, this bit of it. Say, I could say, well, I know tangent is sine theta, sine x over cos x, and then do a little bit and then bring in a bit more. You can't do that. You have to write down the whole expression each time, but you can replace things with something they are equal to. And you can, for instance, this is a multiplication problem. You can distribute. The only number you're allowed to multiply anything by is the number 1, because that doesn't change what you've got. But depending on what form of the number 1 you use, you can make it look different, but it still has the same value. But every line begins with an equal sign. I don't want to see that anywhere in anyone's work. That in math has a very specific meaning. It does not mean equals. It means maps onto. And we're not mapping, we're not working with set theory. I don't see that anywhere in the work. It's not valid math, okay? So the first thing I'm going to do is I'm actually going to distribute. And sometimes you don't know what to do. So you just dive in and try something. And the more of these you've done, the easier it becomes. Tan x times tan x gives you tan squared x. Now, as soon as I see something squared, that makes me think of one of the Pythagorean identities. All of the Pythagorean identities have got things in them that are squared. but there isn't one that just equals tan squared x, and this, oh no, I don't see anything that complex in any of them. So let's see if I can change this first. Now I've got many choices. I'm going to leave that tan squared x as it is for now, and think about what I could do with these. I could change tangent into sine x over cos x. Well, that just makes it into an even bigger hot mess. Changing tan x into sine x wouldn't help me much. It might if I changed cotangent x into cos over sine, and that would simplify and give me the right answer. And it's not wrong. It would work. It just might not be the easiest way. To me, an easier thing to do here would be to leave cotangent x as it is, and tangent x can be replaced. It's equal to 1 over cot x. Now, you've got multiplication in this term here. This is a little term all on its own. That cancels. So we've got 1 plus tan squared x. Oh, yeah, we've got 1. That first one is the 1. That simplifies to 1. Then we've got this plus. Then we've got tan squared x. And when you look at that, I hope those Pythagorean identities, because of those really silly sayings, I hope that just pops into your head. And you go, oh, that's I tan in a second. 1 plus tan squared equals secant squared. Now that is as simple as we can get here. Reduce means roughly the same thing. They're kind of sort of interchangeable as simplify. Write your answer, reduce this, simplify this, so the expression you get is as simple as possible. And the problem in Unit 5.1, it's actually more difficult than when we get on to Unit 5.2. When we're in Unit 5.2, the work looks harder, but it's actually easier because you're told, change this until you end up with, and they tell you what the answer is you're aiming for. On this unit, students often don't know when to stop. The couple of rules I'll tell you that when you know when you can stop. Try and get rid of as many trig functions as you can. Try to end up with just one trig function in your answer. You can have a number as well. Sometimes all the trig functions disappear and all you get left with is a number. And try to get rid of any fractions. This could have been written there. Secant is reciprocal of cosine. So this answer isn't wrong. But because it includes a fraction, it's not as simplified as the secant. So that's not wrong, but this one is a better answer, okay? It's hard to know when to stop sometimes. So that was the first one. Now the second one, when I look at this, just look for things to give you a clue of what to do. As soon as I see something squared, I'm thinking of Pythagorean identity, and this one is the cheesecake one. So that part of it could be replaced with I cut cheesecake, 1 plus cot squared. That one was all with x's. This one we're just using the variable theta. It doesn't matter, but if you're given theta, work with theta. So that's that part. Now I have to write equals, and I have to write out this whole expression. So I don't just write out that blue bit. I also have to write out the -1 divided by the cot theta. Now, in your work on the test or quiz, I'm being really fussy about that. You must write out the entire expression each time. And it's easier if you work vertically, go to another line to do your next part. Unless it's really short, and I guess you could work over here, but it's kind of nice if you work going down. So let's simplify what we've got there. In the numerator, you're adding 1 and you're subtracting 1, those cancel. Now, can somebody turn there? Can you mute yourself, please? Right, this, a lot of people can just get straight from the answers there. If you're not sure, just think about what cot squared theta means. If I had x squared, it could be written as x times x. So this line is optional. You could split cot squared theta into cot theta times cot theta, and then you're dividing by cot theta. Okay, so this cancels that. Another way to show your work is say, I know I've got cot squared there, that's cot times cot. You could just write it like that. Definitely simplified right down. This little piece of work here was optional. Okay, now read what it says at the bottom here. At the end of the last 20 minutes of class today, here, I won't bother recording this bit. So, some hints about how to solve these. Remember that you're replacing expressions with something equal to them. So you're using one of these 11 identities. One technique, if it's quite a simple problem and it hasn't got any fractions or anything squared, try this technique, replacing things like tangent with sine over cos, cotangent with cos over sine. Write everything in terms of sine and cos. Combine fractions over a common denominator. We did one of those yesterday. You're going to do another one in a minute. Look for difference of squares. I'll talk about that a bit more. And factoring expressions, we haven't done any like that. We're going to do an example of that. Okay, let's talk about this looking for difference of squares. Difference of squares is if you have something squared, subtract something else squared. Must be subtract. And it factors to a plus b times a minus b. Now you might you might be given this, and in which case you would factor it to this, or maybe you're given this side, and when you multiply it together, you'll get that difference of squares. If you're looking for, if you've got difference of squares, a huge hint is it's going to be something to do with a Pythagorean identity. Now, if you look at these Pythagorean identities, they're all sum of squares. Two squares added equals one thing. But with these Pythagorean identities, if you manipulate them, you can always say subtract something to the other side. And now you have difference of squares. With this one, you could either subtract the sine or the cosine to the other side. You'd have something like 1 minus cos squared x equals sine squared x. You'd have difference of squares. If you see difference of squares, a hint is you might be able to bring in that Pythagorean identity and get something that looks like a great big hot mess like this and say, oh, that just equals 1. Okay? So look out for difference of squares. We've been using all year and hopefully you'll recognize it quite well. And we're going to have to do one of these. So, did we do number 3 in your class yesterday? Please type into chat yes or no. I know every class did number 4, but did we briefly go over number 3? Okay, yes, we did. So we're not going to do that now. We all did number 4. This is what number 4 looked like. We did it first with numbers, proving you could do it with numbers to remind you of the math. Then we combined two fractions over a common denominator. Now I want you to practice one on your own. So do this one here. Let's give you a couple of minutes to do that. And then I'm going to show you how to do one with factoring. Okay, so when we were looking at this yesterday, remember you're going to multiply those two denominators together. So we're going to have cot x multiplied by 1 plus cosecant of x. And then you're going to have to multiply the numerators as well. This one, to get the denominator right, needs to be, I haven't got room to write all of that blue stuff in there, but we'd be writing all of that there. So this numerator also needs to be multiplied by that. I really haven't got room to write it out nicely, but you're multiplying cosecant of x by 1 plus cosecant of x. So you distribute cosecant of x to the 1 and to the cosecant of x. So this one's numerator here becomes cosecant of x plus cosecant of x squared. Oops, can't see my squared very well there. Okay, and then this denominator, to be the same as the common denominator, needs to be multiplied by this one. So the numerator also needs to be multiplied by that. So that gives us subtract cot squared x. Now, it's a great big hot mess there now, and I haven't even got it written very nicely. One hint I'll give you is don't multiply out that denominator yet. It's probably, the numerator is a great big mess. Let's clean up the numerator first, and things might cancel out. So leave that denominator as it was. I wouldn't have expected you to know that. That's just a hint, something you don't know yet. But don't multiply things out, particularly in the denominator when another part is a great big mess, because things might cancel out. We'll work that out later on. Now, in the numerator, I've got two terms with cosecant in. I've got cosecant x plus cosecant squared x. And this is something totally different. So I'm not going to be able to put all that together and factor it as one lump yet or anything like that. Let's look at these things. These are both squared, which makes me think of a Pythagorean identity. And they're both in the same Pythagorean identity. They're not the same. I can't just cancel them out because they're different trig functions. But they're in their Pythagorean identity, I cut cheesecake. 1 plus cot squared x equals cosecant squared x. So I kind of could replace that, but that would be complicated because the identity doesn't include minus cot squared x. I could manipulate it till it did. But this is one side of the identity. I can replace cosecant squared x, that's like the cheesecake part. I can replace that with 1 plus cot squared x. Okay? That's just this bit. I have to write down everything else as well. So I've had this part here. Don't forget the plus and minus signs. Then I've got that green minus sign. Then I've got that last part. Is what I've just written equal to the line above? Yes, it is. All I've done is I've replaced that part with something it's equal to. Now let's clean this up. Now I'm adding cotangent of x and subtracting cotangent of x. They cancel. And I'm left with something, I can see what to do here because I'm a math teacher, but let's write it out just really clearly. We've got cosecant of x plus 1 is all that's left in the numerator. And we've got cotangent of x times 1 plus cosecant of x. Now, this is a division problem. That entire numerator is the same as this factor. Cosecant of x plus 1, when you're adding things, doesn't matter the order. That's the same as 1 plus cosecant of x. Those are a factor in the numerator, a factor in the denominator, both the same. I can cancel them. Now, does that just leave me with cot x? Not at all. Look at what's left behind when you cancel. First of all, cot x is in the denominator. Have I left nothing in the numerator? No. When you cancel factors, you're leaving behind 1. 1 times it. Okay? So I've only got one trig function, but have I fully simplified it? No, because I've still got a fraction, and I could actually change that. Try and get rid of a fraction if you can. Use a reciprocal identity, that is tangent of x. So that was that one. Now, let's have a look at this next one, factoring. Oh, I've lost a pen. Factoring. With this one, can you see in the numerator we've got something squared, subtract something else squared. We've got difference of squares. Now, in your work, I'm not expecting you to write the stuff with A's and B's. I'm just reminding you how we factor difference of squares. This is difference of squares, and so we're going to replace it with A plus B, A minus B. So sine squared x minus 9 will factor to, you take the square root of the first one, square root of sine squared x is just sine x. That goes at the front of both. Then because it's difference of squares, we're going to have a plus in one, a minus in the other, and the square root of 9 is 3. Then in the bottom, I'm going to have to go and answer the door. Someone's at the door. We have that. See if you can clear that up quickly. Which class period are you in? I'm sorry. This isn't fifth, this is fourth. Okay. Okay, now, so this factor is the same as that, and we are left with sine x minus 3. Looks like I'm not going to get a good recording of the lessons there. I don't know what else is going to go wrong. Okay, let's leave you to try one of these on your own now. Oops. Try this one. This is heading towards, if you read this question, convert from what you've been given first, that's this, convert this into that, just by simplifying. This is leading you into the format of what we're going to do in unit 5.2 as opposed to 5.1. In 5.2, we're doing stuff called verifying. You'll be given a question like this where you're actually given the answer. You're told that this equals that, and it's all about your work. You have to clearly show the work that converts this till it ends up with that. So what we're doing is we're getting this first side and we're going to simplify it till our final answer is there. Can you see in the numerator you've got difference of squares, and in the bottom you've got something that can be factored. So factor it, do some work, simplify it until you're left with that. I'll give you a minute. Okay, so the numerator is difference of squares. It's going to come from sine of theta, because we've got minus there, plus 1 minus, plus minus, and the square root of 25 is 5. How I'm going to factor the denominator is I'm going to use reverse FOIL. So the factors of sine squared are sine and sine. Put sine and sine in the first place in both of them. This middle term comes from a combination of the outer plus the inner, and that 25 at the end is your last term. We look at the last term next. The factors of 25 are 1 and 25 or 5 and 5. Looking here, it's obviously we're going to use 5 and 5. Because this is a plus, what goes here and here must be the same. This is a minus, so they're both going to be minus. Now check. You haven't finished till you've checked. You've got to check that you get negative 10 sine theta as your middle term from the outer added to the inner. This gives the minus 5 sine theta, another minus 5 sine theta. Put them together and you've got minus 10 sine theta. So it worked. The factoring is good. You got that. Now, writing these factors out fully, that is 80% of your work. If you haven't got that written out exactly like that in your work, that I can see, the biggest grade you're going to get on this is like 20%. You must show that line of work. Okay? Then, because everything is multiplication and division, and multiplying, multiplying, dividing, you can cancel out factors that are the same. That cancels that. Now we have got sine theta plus 5 over sine theta minus 5. Okay, done. Any questions at this point? Well, we're done. You can now get on with the exit ticket. Let me pause the video.